Well, hello guys, here Mr. G with another video for the grade 12. This time is question 3 from the test on electric circuit. This is just another question that is developed by Professor Rodriguez. It is an informal test that was done at the Northern Cape in some schools. This question says 3 resistors, 10 ohm, 15 ohm and 5 ohm are connected to a battery of 9 volt of EMF. So note that the EMF of the battery is 9 ohms. An internal resistance of 1,5, and they are also giving you the internal resistance this time in the question, which is 1,5 ohm, as shown in the circuit diagram below. The voltmeter and ammeter are ideals, and the resistance of the conducting wires can be neglected. Okay, so there is the circuit, guys, and let's quickly analyze this circuit real fast. There is a battery which have an EMF of 9, it have an internal resistance of 1,5 ohm. This electric current is going to flow in this direction. As you can see, the circuit is closed, so everything is operating, and then the current is split in two parts there, little bit there, another little bit here, because it is in parallel, and then go back to this side together again, and the current keep flowing all the way to the battery. So that is what is going on here. We have two resistors. These two resistors here are in parallel, the 15 and the 10, because the current split in two at this point, and then the 5 ohm is in series with those two. Calculate the total external resistance of the circuit. Now remember, the total external resistance is equal to resistance in series plus resistance in parallel. Alright, and in this case, remember the 15 ohm and the 10 ohm are in parallel. So we're going to calculate the resistance in parallel real fast at this point. So it's 1 divided by resistance in parallel is equal to 1 divided by resistance 1 plus 1 divided by resistance 2. You don't have to write this formula, but I like to write it. So if you substitute, you have that is 1 divided by 15 plus 1 divided by 10. And then you get that 1 divided by resistance in parallel is equal to 1 divided by 6. So when you fix this one, you get that the resistance in parallel is equal to 1 over 6 to the power minus 1. Be careful, guys, don't forget to do that. So resistance in parallel is equal to 6 ohm. And then when you come back there and you calculate the total resistance, then you get that the total external resistance, let's fix this word here, is equal to, let me just move it a little bit to the left, there we go, is equal to 6 plus 5, and that will be the external resistance be equal to 11 ohm. And this is the end of the first question here. Very easy. Let's go to question 3.2. Calculate the ammeter reading. Now the ammeter reading is the current of the circuit, which is the same in the internal part as well as the external part. Now be careful here. Be careful here. 9 volt is going to be the EMF. So we can actually use the total, the Ohm's law for the whole circuit to calculate this question. Be careful, because you can get confused with 5 and attempt to solve the question using grade 11 way, and that will be no good. So let's do it on this side. 3.2 EMF is equal to the current multiplied by the total external resistance, which we just calculated, plus the internal resistance which we actually have. So the EMF, guys, is 9 volts. We can substitute straightforward. The current, I don't know what that be coming from. The current multiplied by the external resistance, which is 11, plus the internal resistance, which is 1,5 volts. So if you solve this one here, you get that is 9 divided by 12,5, and then you will get that the current in the circuit is going to be equal to 0,72 ampere. That is the current for the circuit. Question 3.2 done and dusted. Let's go to question 3.3. Calculate the reading of voltmeter V2. Now V2 is here and V2 is reading, let's mark it here so you can see what we are working with. V2 is reading the potential difference across the 10 ohm resistor. However, because the 10 ohm resistor is in parallel with the 15 ohm resistor, V2 is also measuring the potential difference across the parallel, because in parallel potential difference is the same. So for this question, we are going to select the parallel connection as the part of the circuit of interest here. So in this case, what we have that the current in parallel is equal to 0.72 in the whole parallel, not of individual one. Be careful with that one there. So what we're going to do, we're going to use the formula that they give us in the exam. Let's go to the formula so you can see there's still one more question to do. The question, guys, is this one here. This one is for part of a circuit. Let me write it here. Part of a circuit. Part of a circuit, and in this case we're going to take the part of the circuit to be the parallel connection there. Okay, so we are going to write the formula as it is there. Resistance is equal to potential difference. We're going to working with a parallel connection. So let's write resistance in parallel is equal to potential difference in parallel divided by current in parallel. And when you substitute what we have, the resistance in parallel is 6. Note it was calculated previously. This equal to a potential difference in parallel divided by the current in parallel, which is going to be 0.72. guys, if you rearrange this one, you get that potential difference in parallel is equal to 6 multiplied by 0.72, and then you get that the potential difference is equal to 4.32 volt. This is therefore the potential difference across the parallel connection as well as the potential difference across the 10 ohm resistor, because it is the same because they are in parallel. And then this is the answer for question, let's write it here, 3.3. There we go. So far so good. Define the term power in word. And guys, when you go to the formulas, I want you to note, and please take the note there in your book. This formula here is the definition for power. Definition for power. There we go. So all we have to do in the exam, if we don't remember, is come to the exam, look for this formula here, and then translate it into words. So that's all. When you say this one, remember that anything you divide by time, we can say rate. So the definition of power is that formula, and is going to be said like the rate or at which work is done. It's one of the easiest definitions that you are going to be asked in the exam, and is a high probability of being asked in the September or end of the year. Question 3.5, calculate the power dissipated by the 5 ohm resistor. So you have to calculate the power in the 5 ohm. What we have the current, we have the resistance. The current was calculated, and remember it's going to be the same everywhere. So we once more go to the formula, guys, and look for the formulas. In this case, this one is the one that is more suitable according to the data we have, because we have the current and we have the resistance there. So if we go back, let's go back to the question. Let me go like this. There we go. So we can calculate the power for the 5 ohm resistor. This one is question 3.5. Okay, so in question 3.5 you have that power is equal to current to the power 2 multiplied by resistance. I just copy the formulas, it is there. So the power is equal to current, which is going to be 0.72 square multiplied by the resistance, which is 5. So when you calculate that one, you get that the power is going to be equal to 2.59 watt. That is the answer for question 3.5. Guys, take note, right? Don't just look the video. This is not a movie. So we go to question 3.6, and then is the final question of this question 3. How does the reading of the ammeter change when the switch S is open? Now let's identify switch S. Okay, there we are. Now switch S, let's fix this one. If switch S is open, guys, what is happening? If switch S is opening, you will have only one path for the current. So therefore, if switch S is open, the total external resistance is going to increase. Now this one could be the most difficult and tricky question in this question 3. Let's see what are important points. In this question, what we have to say? First of all, we have to say that the total external resistance increase. The total, this one is 3.6. The total external resistance increase. Okay, and remember, we're talking if we go to the external part of the circuit, current is equal to a potential difference, external part of potential difference divided by external resistance. If the external resistance change or increase, then the current will decrease. So the answer here is decrease. And then guys, this is the end of the question. I hope it helped. It's a good question to practice. If it did help, guys, don't be stingy. Thumb up and subscribe for the channel. I'll see you next time with another question. We're going to be answering question 4 from this test, which you can see here. So I'll see you next time. Thank you for watching. Subscribe for the channel, thumb up. Mr. G here.